So let us look at further logarithm. We want to look at the questions that are touching on further logarithm as a topic. And before we embark on each and every question, it will be good that we remind ourselves of the basic laws of further logarithm. So in further logarithm, there are some laws that we need to know. They are the laws that are going to guide us as we are going to solve various kind of questions that are touching on further logarithms. So the laws of logarithm, we have got number one. We know that if you have got log of A plus log of B, this is supposed to be equals to log of A times B. For example, if we have got log of 10 plus log of 20, this is supposed to be equals to log of 10 times 20, which will give us log of 200. Number two, if we have got log of A minus log of B, this is supposed to be the same as log of A over B. For example, if you have got log of 100 minus log of 10, we must know that that will be the same as log of 100 over 10, which will give us log of 10. Number three, we must know that if we have got log of A to power B, this is the same as B log of A. For example, if we have got log of 2 to power 3, this can be written as 3 log of 2. Or if you have got log of 5 to power a half, this can be written as a half log of 5. Another law that we need to know, if you are given number 4, we must know that log of a number to its base is equals to 1. For example, if we have got log of 5 to base 5, this is equal to 1. If we have got log of 6 to base 6 is equals to 1. If you have got log of 10 to base 10, it's supposed to give you 1. So that is also another law that we need to know. Number 5, we need also to know that log of 1 to any base is equal to 0. For example, log of 1 to base 2 is 0. Log of 1 to base 10 is 0. Log of 1 to base 9 is 0. Log of 1 to any base is 0. Log of 1 to any base is 0. Another law that is going to guide us, we can also say that log of A to base B. Log of A to base B is equals to 1 over log of B to base A. For example, if we have got log of 6 to base 10, this can be written as 1 over log of 10 to base 6. So these are the basic law of logarithm that we need to know, because they are the ones that are going to guide us as we are going to solve various kinds of questions that are touching on further logarithm. Another important area that we also need to arm ourselves with, if you are given A to power B is equals to Y, you must know that this is in terms of index notation. In logarithmic notation, you'll say log of Y to base A is equals to B. This is logarithmic notation. Logarithmic notation. For example, if you have got log of 8 to base 2 should give us 3. This is logarithmic notation. What about in terms of index notation? In terms of index notation, we'll say 2 to power 3. This 2 to power 3 should give us 8. If we have got log of 100 to base 10 is equals to 2, this is logarithmic notation. In index notation, we'll say 10 to power 2 is equals to 100. So that is also something that we need to know, because it is also going to guide us as we are going to solve various kinds of questions that are touching on further logarithm. So let us embark to number 1. In number 1, we are told solve the equation 2 log of x plus a half log of 81 is equals to log of 6. So let's rub here so that we look at the question together. So 2 log of x. Remember that if we are given b log of a, this can be written as log of a to power b. For example, if you are given 3 log of 2, we must know that that is the same as log of 2 to power 3. So if we have got 2 log of x, this can be written as log of x to power 2. So instead of having 2 log of x, we can have log of x to power 2. Then plus, if you have got a half log of 81, this can be written as log of 81 to power a half. A half log of 81 can be written as log of 81 to power a half. This is the law that we are applying. And you must know that 81 to power a half is the same as the square root of 81. Because if you are given a number to power 1 over 2, you must know that that is the same as the square root of that number x. If it is x to power 1 over 3, this is the same as the third root of x. If it is x to power 1 over 4, this is the same as the fourth root of x. So if we have given 81 to power a half, we must know that that is the square root of 81. So in our case here, we have 81 to power a half, which is the same as square root of 81, which gives us 9. So instead of having log of 81 to power a half, we are going to have log of 9. So in this case, we are going to have log of 9, giving us log of 6x. So we also know that if you have got log of a plus log of b, this is the same as log of a times b. So if we have got log of x squared plus log of 9, this is the same as log of x squared times 9 should give us log of 6x. So this one cancel out. We are left with x squared times 9 equals to 6x. This is 9x squared equals to 6x. 9x squared minus 6x equal to 0. So we look at the common factor here. The common factor is 3x going into 9x squared 3x times. And into minus 6x, it goes there too. giving us 0. So we have got 3x into 3x minus 2 equal to 0. So this is going to give us 3x is equal to 0, or 3x minus 2 is equal to 0. So x alone is 0, or x alone is 2 over 3. And that is how to solve that question. Number 2. Number 2, we are given log of y to base 2 minus 2 equals to log of 92 to base 2. Let's collect the like term first. We can say log of y to base 2 minus log of 92 to base 2 should give us 2. We bring this one, we bring log of 92 to base 2 to the left and negative 2 to the right. Then, because we know the laws of logarithm, log of a minus log of b is the same as log of a over b. So log of y minus log of 92, everything to base 2, is the same as log of y over 92, everything to base 2 is equals to 2. Then we want to do away with the log to base 2. So for us to do away with it, on the left hand side, we must convert 2 into log of something to base 2, so that by the end of the day, we still have 2. So we want to make sure that on the left hand side, we have got log of a number to base 2, which is still going to give us 2. So in terms of index and logarithmic notation, we said that if you have got index logarithmic notation like this, then you can convert it into index notation so that you get the value of y. In index notation, you'll say 2, this 2 to power 2 is equals to y. So 4 is equals to y. So we have log of 4, which is y, to base 2 is giving us 2. So instead of having 2 on the left-hand side, on the right-hand side, we can have log of 4 to base 2. So we'll have log of y over 92 to base 2 should give us log of 4 to base 2. So this one cancel out. So we have got y over 92 should give us 4. So y is equals to 92 times 4, we have 8, we have 36, 368, and that is the answer for that. Number 3. Number 3, solve for x in log of 3x plus 4 minus log 3 minus x in bracket equals to 1. So we have got log of 3x plus 4 in bracket minus log of 3 minus x equals to 1. So we know that if we are given log of a minus log of b, then we are supposed to have log of a over b. So if we have got log of 3x plus 4 minus log of 3 minus x, this can be written as log of 3x plus 4 over 3 minus x equals to 1. So we want to convert this one into log form so that it becomes log of something to base 10, because If you are not given the base, you must know that everything is to standard base 10. So we want to convert we want to convert 1 to read log of something to base 10, which is going to give us 1. So if we have got log of y to base 10 should give us 1. What is y? So this is in terms of logarithmic notation. If we want to find the value of y, we convert everything into index notation. And we'll say 10 to power 1. Power 1 should give us y. So y is equals to 10. So we have log of 10 to base 10 should give us 1. So instead of having 1 here, we can have log of 10 to base 10. So we'll have log of 3x plus 4 over 3 minus x, everything to base 10 should give us log of 10 to base 10. So this one cancel out. We are left with 3x plus 4 over 3 minus x equals to 10. So cross multiply, you'll get 3x plus 4 is equals to 10 in bracket 3 minus x. 3x plus 4 should give us 30 minus 10x. Collect the like terms. 3x plus 10x should give us 30 minus 4. So that is going to give us 13x should be equals to 26. X alone is equals to 26 over 13. X is equals to 2. And that is the answer for that. Number 4. Let's look at, we have got 2 to power 2, which is 4, plus log of x squared to base 2, plus 5 log of 2 to base 2 can be written as log of 2 to power 5 to base 2. Because we know that if we have got b log of a, even to base 10 should give us log of a to power b to base 10, like that. So if we have got 5 log of 2 to base 2 should give us log of 2 to power 5 to base 2. And this is supposed to give us log of 32 to base 2. So we'll have log of 32 to base 2 equals to 9. So we'll have log of x squared to base 2 plus log of 32 to base 2 equals to 9. Bring this 4 to the right hand side, minus 4. So log of x to power 2 to base 2 plus log of 32 to base 2 is equals to 5. Then we know that log of a plus log of b should give us log of a times b. So instead of having log of x squared plus log of 32, everything to base 2, we can have log of x squared times 32 to base 2 should give us 5. So that is going to give us log of x squared times 32, everything to base 2 should give us 5. We must convert this into a log form. If you have got 5, we say log of what can be y to base 2, this base to base 2 is going to give us 5. Let me rub. We are saying log of what? Y to base 2 should give us 5. So we need to find y. For us to get y, we convert this into index notation. We convert this into index notation and it will say 2, this 2 here, to power 5. Power 5 should give us y. So 2 to power 5 is 32, should be equals to y. So it is the same as log of 32 to base 2 should be equals to 5. So instead of having this 5, we can have log of 32 to base 2. So that log to base 2 cancel out. So we are left with x squared times 32 should be equals to 32. So divide both sides by 32. Divide both sides by 32. So x squared is equals to 1. So x is equals to square root of 1. So x is equals to plus 1 or x is equals to minus 1. And that is the answer for that. Number 5. Let's look at number 5. Solve for y in the equation. We are given log of y to base 2 should be equals to log of 3 to base 2 plus log of 7 to base 2 plus 2 log of y to base 2. So we know that if we have got log of a plus log of b plus log of c, this is the same as log of a times b times c. So if we have log of y to base 2 should be equals to log of 3 to base 2 plus log of 7 to base 2 plus, let's remember, b log of a can be written as log of a to power b. So 2 log of y can be written as log of y squared to power 2 to base 2. Y squared to base 2. So this side, we can apply this. Can say log of y to base 2 should be equals to log of 3 times 7 times y squared, everything to base 2. So this one cancel out. We have got y is equals to 21 y squared. So we have 0 is equivalent to 21 y squared minus y. So we have 21 y squared minus y is equal to 0. So common factor is y. So we have got y in bracket 21y minus 1 is equivalent to 0. So y is equal to 0 or 21y minus 1 is equal to 0. So y is equal to 0 or y is equal to 1 over 21. That is the answer for that. Number 6. Solve for x in log 2x plus 4 minus log x minus 1 equals to 3 log of 2. So remember our laws. We are saying log of a plus log of b is equals to log of a times b. So log of 2x plus 4 minus log of x minus 1. We cannot apply this. Let's apply log of a minus log of b. This is supposed to be equals to log of a over b. So log of 2x plus 4 minus log of x minus 1 is the same as log of 2x plus 4 over x minus 1 should be equals to, we know that b log of a can be written as log of a to power b. So this is log of 2 to power 3. So that will give us log of 2x plus 4 over x minus 1 should be equals to log of 8, because 2 to power 3 is 8. So log cancel out. 2x plus 4 over x minus 1 is equals to 8. 2x plus 4 is equals to 8 in bracket x minus 1. So 2x plus 4 is equals to 8x minus 8. Collect the like terms. 2x minus 8x is equals to minus 8 minus 4. So minus 6x is equals to minus 12. So x alone is equals to minus 12 over minus 6. X is equals to 2. And that is the answer for that. Number 7, given that log of 3 is equals to 1.583 and log of 5 is equals to 2.322. Evaluate without using tables or calculators log of 75. We have got log of 75. This can be written as log of 25 times 3, because we know that 25 times 3 will give us 75. So log of 25 times 3 can also be written as log of 25 plus log of 3, because we know that log of a times b is the same as log of a plus log of b. So this is the same as, so we now have log of 25 plus log of 3. This is the same as log of 5 squared plus log of 3, because 5 squared is equal to 25. And we know that log of a to power b can be written as log of b log of a. So if we have got log of 5 to power 2 can be written as 2 log of 5. So we'll have 2 log of 5 plus log of 3. So in our case, log of 3 was given and log of 5 was given. So instead of having log of 5, we'll have 2 times 2.322 plus log of 3, which is 1.583. So we have 2.322 multiplied by 2, we get 4.464. So we have got 4.644 plus 1.583. 4.644 plus 1.583 is equal to 7.226. So our answer is 6.227. That is the answer for that. Number 8. Solve for x given log of 48 to base 4 plus log of 24 to base 4 minus log of x, 2 log of x to base 4 equals to 5 over 2. So we are still applying the laws of logarithm. We have log of 48 to base 4 plus log of 24 to base 4 minus, we have 2 log of x to base 4. This one can be written as log of x to power 2 to base 4. So we have minus log of x to power 2 to base 4 equals to 5 over 2. Now that log of a plus log of b is equals to log of a times b. So this is, we have got log of 48 to base 4 plus log of 24 to base 4. This can be written as log of 48 times 24 everything to base 4 minus log of x squared to base 4 equals to 5 over 2. So we know that 48 times 24, this one is 2, 192, this one is 16, this one is 8, 8, 8, 9. So we'll get 2, 5, 10, 11. So we have log of 1152 to base 4 minus log of x to power 2 to base 4 equals to 5 over 2. Then we know that log of a minus log of b, this is the same as log of a over b. So log of 1152 to base 4 minus log of x squared to base 4, this can be written as log of 1152 over x squared everything to base 4 is equals to 5 over 2. Then this one, we must express it in log form. Log of something to base 4. Log of something, for example, y to base 4, that is going to give us 5 over 2. This is in terms of logarithmic notation. If we want to find y, we must convert it into index notation. So we'll say 4 to power 5 over 2 should be equals to y. And that is the same as 4 to power a half everything to power 5 is equals to y. And we said last time that a number to power a half is the same as the square root of that number. So this is the same as the square root of 4, but you raise it to power 5, should give you y. So that will give you 2 to power 5, will give you y. So y will be equals to 32. So we know that log of 32 to base 4 should give us 5 over 2. So instead of having this 5 over 2 here, we'll have log of 32 to base 4. So we'll have log of 1152 over x squared to base 4 should give us log of 32 to base 4. So the base and the log are going. We are left with 1152 over x squared is equals to 32. So that means 1152 is equals to 32 x squared. So divide both sides by 32 by 32. Can say 2 goes here 16, 2 goes here 5, into 15 7, into 12 6. 2 goes there 8, 2 goes here 2, into 17 8, into 16 8. Then 2 goes here 4, 2 goes here 1 4 4. 4 goes here 1, 4 goes there 3, into 24 6. So we'll have x squared is equals to 36. X alone is square root of 36. X is equals to 6. Number 9. Solve for x in the equation log of 4 to base x plus log of x to base 4 equals to 2. So we are given log of 4 to base x plus log of x to base 4 is equals to 2. This is the equation that we have. So for us to solve this, we know that log of 4 to base x can be written as log of 1 over log of x to base 4. I repeat, if you are given log of b to base a, this can be written as 1 over log of a to base b. That is why we are saying if we have got log of 4 to base x, this can be written as 1 over log of x to base 4. So instead of having this, let's have 1 over log of x to base 4 plus log of x to base 4 equal to 2 equals to 2. So at this stage we'll say let y equals to log of x to base 4. So if y is equals to log of x to base 4, then we'll have 1 over y plus y equals to 2 over 1. So LCM is y. Y goes into y 1 times. 1 times 1 is 1 plus 1 goes into y 1 goes into y times y is y squared is equals to 2. So we have 1 plus y squared over y is equals to 2. So that tells us that 1 plus y squared is equals to 2y. Cross multiply. So we'll have 1 plus y squared minus 2y is equal to 0. So we have y squared minus 2y plus 1 equal to 0. Look for two numbers that if you multiply will give you positive 1, and if you add will give you minus 2. So those two numbers are minus 1 and minus 1. So we are going to have y squared minus y plus 1 equal to 0. Collect common factor. We have y in bracket y minus 1 minus 1 in bracket y minus 1 equal to 0. So y minus 1 in bracket y minus 1 is equal to 0. Y is equal to 1 or y is equal to 1. So we get that y is equivalent to 1. But what was our y? We said y was equivalent to log of x to base 4. So we can say log of x to base 4 is equals to 1. So what is x? This is logarithmic notation. If you want to convert it into index notation, you'll say 4, this 4 to power 1, this 1 is equals to x. So x is equals to 4. That is the answer for that. Number 10. Number 10, solve the simultaneous equations. We are given log of 2x plus y to base 3 is equals to 2, and log of 3x plus 4y to base 2 is equals to 4. So if we are given log of 2x plus y to base 3 is equals to 2, then we can convert these two here into log form so that we have log of something, log of a number to base 3, that is going to give us 2. You can say log of y to base 3, that is supposed to give us 2. So once we have this, we know that this is logarithmic notation. If we want to get the value of y, we must convert this into index notation. And we'll say 3, this 3 here, to power this 2. To power 2 should give us y. So that means 9 should be equals to what? Y. So we'll have log of 9 to base 3 is equivalent to 2. So instead of having 2 here, we can have log of 9 to base 3. So we'll have log of 2x plus y to base 3 is equals to log of 9 to base 3. So that cancel out like that. So we'll have 2x plus y is equals to 9, equation 1. Then let's go to equation 2. We have log of 3x plus 4 to base 2 should give us 4. So this 4 must be converted into a log form so that we have got log of something. Can have log of y to base 2. It must be converted into log of something to base 2. So log of y to base 2 should give us 4. You know that this is index notation, logarithmic notation. If you want to get the value of y, we convert it into index notation. You'll say, you'll take 2, this 2 here, to power 4 should give us y. So that is 16 should be equals to y. So we are saying log of 16 to base 2 should be equals to 4. So instead of having 4, we get log of 16 to base 2. So log of 3x plus 4 to base 2 should be equals to log of 16 to base 2. So this one cancel out. we have 3x plus 4 should be equals to 16, equation 2. So we have got the first equation, which is 2x plus y is equals to 9, and 3x plus 4 plus 4 should be equals to 16. I hope I'm right. It is plus 4y plus 4y, 4y plus 4y plus 4y should be equal to 16. So we can eliminate x, multiply by 3 by 2. So we have 6x plus 3y is equals to 27. And this one we have got 6x plus 8y should be equals to 32. So that will give us 0 minus 5x should be equals to minus 5. So x alone is minus 5 over minus 5. X is equals to 1. So x is equals to 1. What is y? So we can choose any of the equation. 2x plus y should be equals to 9. And x is 1. So 2 times 1 plus y is equals to 9. So 2 plus y is equals to 9. Y is equals to 9 minus 2. Y is equal to 7. And that is the answer for that. Number 11, given that log of 3 is equal to r, express the following expressions in terms of r. So we have got log of 10 over 3 minus log of 1 over 27 plus log of 81. We know that log of a minus log of b, log of a minus log of b is equals to log of a over b. So log of 10, this log of 10 over 3 minus log of 1 over 27 can be written as log of 10 over 3 divided by 1 over 27. So that will give us log of 10 over 3 times 27. Then we add to log of 81. So 3 goes here 1, 3 goes here 9. So we have got log of 10 times 9 plus log of 81. So this will give us log of, you know that if we have got log of a times b should be equals to log of a plus b, log of b. So this will give us log of 10 plus log of 9 plus log of 81. So log of 10 will have log of 10 plus log of 3 to power 2 plus log of 3 to power 4. This will give us log of 10 plus 2 log of 3 plus 4 log of 3. And we are told that log of 3 is equals to r. Log of 3 is equals to r. So we have log of 3 is equals to r. So where log of 3 is, we replace with r. So we'll have log of 10 plus 2 times r plus 4 times r. So we'll have log of 10 plus 2r plus 4r. And log of 10 is 1. Log of 10 is 1 plus 2r plus 4r. This will give us 1 plus 6r. That is the answer for that. Number 12. Without using tables or calculators, evaluate. Without using tables or calculators, evaluate. We are given log of 729 minus log of 81 over log of 3. So we know that if we have got log of A minus log of B can be written as log of A over B. So log of 729 minus log of 81 can be written as log of 729 divided by 81. Everything over log of 3. So we can say 3 goes here 27 times, 3 goes here 2, 4, 3. 3 goes here 9 times, 3 goes here 8, 1. 9 goes here 1, 9 goes here 9. So we'll have log of 9 over log of 3. This is the same as log of 3 squared over log of 3. So that will give us, you know that log of a to power b can be written as b log of a. So this will give us 2 log of 3 over log of 3. You cancel out log of 3 and log of 3. We remain with 2. That is the answer for that. Number 13. Solve for x given. So we have log of x plus 7 to base 27 minus log of x minus 1 to base 27 equals to 2 over 3. So we know that if we have got log of a minus log of b, this is supposed to give us log of a over b. So here we have got log of x plus 7 minus log of x minus 1. That is supposed to give us log of x plus 7 over x minus 1. Everything to base 27 should give us 2 over 3. This 2 over 3, we want to put it in log form so that we have got log of a number to base 27 giving us 2 over 3. We want to have log of a number y to base 27 should give us 2 over 3. This is logarithmic notation. If we are to get the value of y, we convert it into index notation and we'll say 27 to power 2 over 3 is supposed to give us y. So this is the same as 27 to power 1 over 3. Everything squared is equals to y. So that is the third root of 27. If you square it, should give you y. So the third root of 27 is 3. Squared should give you y. So 9 is equals to y. So we have got log of, we'll have log of y, which is 9 to base 27, should give us 2 over 3. So instead of having 2 over 3, we have log of 9 to base 27. Let's look at number 13. We are given log of x plus 7 to base 27 minus log of x minus 1 to base 27 is equals to 2 over 3. And we know that if we have got log of A minus log of B, this should be equals to log of A over B. So log of x plus 7 to base 27 minus log of x minus 1 to base 27 can be written as log of x plus 7 over x minus 1, everything to base 27 should be equals to 2 over 3. So 2 over 3, we want to express it into log of something, log of a number y to base 27. So if you want to find the value of y here, if you want to find y, you must know that this is logarithmic notation. So if we want to get y, we convert the whole of this equation into index notation. Then we'll say 27, this 27 here, to base to power 2 over 3 should be equals to y. So this is the same as 27 to power 1 over 3, everything to power 2 is equals to y. This is the same as the third root of 27 should be equals to y. Let's know that this is squared. It's squared. So this is going to give us 3 squared is equals to y. So 9 is equals to y. So instead of having 2 over 3, we can have log of 9 to base 27 will give us 2 over 3. So in our case here, instead of having 2 over 3 here, we'll say log of x plus 7 over x minus 1 to base 27 should be equals to log of 9 to base 27. So this one cancel out. We are left with x plus 7 over x minus 1 is equals to 9. So that will give us cross multiply. You'll have x plus 7 should be equals to 9 in bracket x minus 1. X plus 7 should be equals to 9x minus 9. X, collect the like terms, x minus 9x should be equals to minus 9 minus 7. Minus 8x should be equals to minus 16. X alone should be equals to minus 16 over minus 8. X alone is equals to 2. And that is the answer for that. Number 14. Without using logarithm tables, solve for x in the equation below. So we are given log of 11 over 2 plus 2 log of 4 over 11 minus log of 5 over 22 should give us 2 log of 4 minus log of x. So we can begin with the first two, and we can say this is the same as log of 11 over 2 minus, remember if you have got b, log of x, this can be written as log of x to power b. So if we have got 2 log of 4 over 11, we must know that that can be written as log of 4 over 11 everything to power 2. So this will give me log of 4 over 11 to power 2. Then we can bring in this and say minus log of 5 over 22 will give us, if we have got b log of x, we are saying it is the same as log of x to power b. So if we have got 2 log of 4, this is the same as log of 4 to power 2. So this one, we'll write it now, log of 4 to power 2 minus log of x. So this will give us log of 11 to power 2 minus log of 16 over 121 minus log of 5 over 22 should give us log of 16 minus log of x. So if we take the first two, then we'll have, because we know that log of a minus log of b should give us log of a over b. So log of 11 over 2 minus log of 16 over 121 will be equals to log of 11 over 2 divided by 16 over 121. Then we minus log of 5 over 22. 5 over 22 Number 14. Number 14, without using logarithm tables, solve for x in the equation below. So we are given log of 11 over 2 plus 2 log of 4 over 11 minus log of 5 over 22 equals to 2 log of 4 minus log of x. So we'll have log of 11 over 2 plus 2 log of 4 over 11 can be written as log of 4 over 11 squared, which is the same as log of 16 over 121. So we'll have here log of 16 over 121 minus log of 5 over 22 is equals to 2 log of 4 should be the same as log of 4 squared, which is the same as log of 16. So this is the same as log of 16 minus log of x. So if we start with this, we'll say this is the same as log of 11 over 2 times 16 over 121 minus log of 5 over 22 should give us log of 16 over x, because we know that if we have got log of a minus log of b, this is supposed to give us log of a over b. So we can say 2 goes here once, 2 goes here 8, 11 goes here 1, 11 goes here 11 times. Then we'll have log of 8 over 11 minus log of 5 over 22 should give us log of 16 over x. So this will give us log of 8 over 11 divided by 5 over 22 should give us log of 16 over x. So the log cancel out. Then we have got 8 over 11 divided by 5 over 22 should give us 16 over x. So this is the same as 8 over 11 times 22 over 5 should give us 16 over x. So 11 goes here 1, 11 goes here 2. We have got 16 over 5 should give us 16 over x. So x alone will be equals to 16 times 5 over 16. X alone will give us 5, and that is the answer for that. Solve for x in the equation. Number 15, solve for x in the equation. We have got 2 log of x to base 10. And we know that if we have got b log of x, this is supposed to be the same as log of x to power b. So if we have got 2 log of x to base 10, this is the same as log of x to power 2 to base 10. So instead of having 2 log of x to base 10, we'll have log of x to power 2 to base 10 plus log of 5 to base 10 plus 1. If we want to convert 1 into log of a number to base 10, so this is logarithmic notation. If you convert it into index notation, you'll say 10. This 10 here to power this 1 should give us y. So 10 to power 1 is equals to y. So that means 10 is equals to y. So we have got 1 is equivalent to log of 10 to base 10. So instead of having 1 here, can have log of 10 to base 10. And this will be equal to sign plus 2 log of 4 to base 10 should be the same as log of 4 squared to base 10, which is supposed to give us log of 16 to base 10. So we have got log of 16 to base 10. Then we now have, if you have got log of a plus b, log of b, you know that this can be written as log of a times b. So log of x squared to base 10 plus log of 5 to base 10 can be written as log of x squared times 5 everything to base 10 should be equals to log of, we have got log of 10 to base 10 plus log of 16 to base 10. That will be log of 10 times 16 everything to base 10. So this one cancel out. We now remain with x squared. 5x squared is equals to 160. So x alone is equals to 160 divided by 5. X squared alone should be equals to 32. X should be equals to the square root of 32. And that is the answer for that. Number 16, find the value of x. Find the value of x that satisfies the equation. So we are given We are given log of 2x minus 11 minus log of 2 equals to log of 3 minus log of x. We know that if we have got log of a minus log of b should be equivalent to log of a over b. So log of 2x minus 11 minus log of 2 can be written as log of 2x minus 11 over 2 should give us log of 3 over x. So log will cancel out. We are left with 2x minus 11 over 2 should be equals to 3 over x. Cross multiply. We'll have x in bracket 2x minus 11 should be equals to 2 times 3. So 2x squared minus 11x should be equals to 6. So we'll have 2x squared minus 11x minus 6 equal to 0. So 2 times minus 6 is minus 12. We look for two numbers that if you multiply will give you minus 12, and if you add will give you minus 11. And that is minus 12 and 1. So we'll have 2x squared minus 12x plus x minus 6 equal to 0. Collect the like terms. So we'll have 2x in bracket x minus 6 plus 1 in bracket x minus 6 equal to 0. So we have 2x plus 1 in bracket x minus 6 equal to 0. So 2x plus 1 is equivalent to 0, or x minus 6 is equal to 0. So x is equal to minus a half, or x is equal to 6. That is the answer for that. Number 17. Without using logarithm tables, find the value of x in the equation. So we are given log of x to power 3 plus log of 5x equals to 5 log of 2 minus log of 2 over 5. So let's begin with the left hand side. We have got log of x to power 3 plus log of 5x. And we know that if we have got log of a plus log of b, this can be written as log of a times b. So we have log of x to power 3 plus log of 5x can be written as log of x to power 3 times 5x should give us, we know that if it is b log of x, this can be written as log of x to power b. If you have got 5 log of 2, this can be written as log of 2 to power 5, giving us log of 32. So this 5 log of 2 can be written as log of 2 to power 5. We take away log of 2 over 5. So that will give us log of 5x to power 4. So will be equals to log of 32 minus log of 2 over 5. So we have got log of 5x to power 4 should give us log of, if we have log of a minus log of b, should be equals to log of a over b. So we'll have log of 32 divided by 2 over 5. So we have log of 5x to the power 4 should be equals to log of 32 times 5 over 2. This one cancel out, it goes there 16. Log of 5x to the power 4 should be equals to log of 80. Then we can cancel the log. We remain with the x. 5x to the power 4 should be equals to 80. X to the power 4 should be equals to 80 over 5. So x to the power 4 should be equals to 16. X is supposed to be the fourth root of 16. So x is equals to 2. That is the answer. Number 18. Find x if... Number 18. Find x if minus 3 log of 5 plus log of x squared is equals to log of 1 over 125. So let's begin with minus 3 log of 5. We have got minus 3 log of 5. We know that if you have got b log of x, it can be written as log of x to power b. So this can be written as log of 5 to power 3 plus log of x squared should be equals to log of 1 over 125. So this will give us log of 5 to power minus 3 times x squared should give us log of 1 over 125. So the log cancel. So we have got 5 to power minus 3 times x squared should give us 1 over 125. So 1 over 125 can be written as 1 over 5 to power minus 3 power 3. 5 to power 3 because 125 is equal to 5 to power 3. So we'll have 5 to power minus 3 times x squared should give us 1 over 5 to power 3. 5 to power minus 3 times x squared should give us 1 over 5 to power 3 can be written as 5 to power minus 3. So we'll have 5 to power minus 3. So this will cancel out and you'll be left with x squared is equals to 1. So x alone is square root of 1. X is equals to plus 1 or x is equals to minus 1. Number 19. Solve for x log of x to base 3 everything squared minus 1 over 2 log of x to base 3 equals to 3 over 2. So what we are going to have here, we have got log of x to base 3. We can say let y to be equals to log of x to base 3. So instead of having log of x to base 3, we are going to have y, then we square it because of this, minus a half log of x to base 3, and log of x to base 3 is equals to y. So minus a half y should give us 3 over 2. So the LCM on the left hand side is 2. 1 goes into 2 times, so we'll have 2y squared minus y equals to 3 over 2. So we'll have 2y squared minus y should be equal to 3 over 2 times 2, because you cross multiply. So 2 cancel out. 2y squared minus y should give us 3. So we'll have 2y squared minus y minus 3 should be equal to 0. We take 2 because this is a quadratic equation. We take 2, we multiply it by minus 3, we get minus 6. Then we look for two numbers that if you multiply is going to give you minus 6, and if you add is going to give you minus 1. So those are minus 3 and plus 2. So we'll have 2y squared plus 2y minus 3y minus 3 equal to 0. 2y is common in bracket y plus 1, minus 3 is common in bracket y plus 1 equal to 0. So 2y minus 3 in bracket y plus 1 equal to 0. So we'll have 2y minus 3 is equivalent to 0, or y plus 1 is equivalent to 0. So this means 2y is equals to 3 and y is equals to 3 over 2, which is the same as y is equals to 1.5, or y is equals to minus 1. And that is the answer for that. Number 20. Find the value of x that satisfies the equation. So we are given log of x plus 24 minus 2 log of 3 equals to log of 9 minus 2x. So we'll have log of x plus 24. We know that if we are given b log of x, this can be written as log of x to power b. If you have got 2 log of 3, this can be written as log of 3 to power 2, which is equal to log of 9. So in our case here, we have got 2 log of 3. We are saying it can be written as log of 9 should be equals to log of 9 minus 2x in bracket. We know that log of a minus log of b is equivalent to log of a over b. So in our case, we have got log of x plus 24 minus log of 9, which can be written as log of x plus 24 over 9. Everything in bracket should be equal to log of 9 minus 2x. So the log cancel each other. We remain with x plus 24 over 9 should be equals to 9 minus 2x. Cross multiply, we'll have x plus 24 should be equals to 9 in bracket 9 minus 2x. So x plus 24 should be equals to 81 minus 18x. Collect the like terms. You'll say x, 18x, when it comes on the left hand side, it will come plus 18x, so it will be equals to 81 minus 24. So this will give us 19x should be equals to, if we have got 81 minus 24, this will give us, we'll get there 7, and this remaining 7 minus that 57. So we'll have 57. So x alone will be equals to 57 divided by 19. So x will give us 3 because 19 goes there 1 and it goes there 3. So x is 3, and that is the answer for that. Let's look at number 21. We are told solve for x, given that log of x plus 5 equals to log of 4 minus log of x plus 2 in bracket. So we have got log of x plus 5 equals to log of 4 minus log of x plus 2. This gives us log of x plus 5 should be equals to, we know that if we have got log of a minus log of b, this is supposed to be equals to log of a over b. So in our case here, we have got log of 4 minus log of x plus 2. That's supposed to give us log of 4 over x plus 2, everything in bracket. So the log cancel. We are left with x plus 5 should give us 4 over x plus 2. So cross multiply, you'll have x plus 5 in bracket x plus 2 should be equals to 4. So x squared plus 2x plus 5x plus 10 equals to 4. What I've done, I've expanded and I've broken. I've done away with the bracket. So this will give me x squared plus 7x plus 10 equals to 4. Collect the like terms. We'll have x squared plus 7x plus 10 minus 4 equal to 0. So we'll have x squared plus 7x plus 6 equal to 0. So we look for two numbers that if you multiply, you are going to get positive 6, and if you add, you are going to get positive 7, and that is 6 and 1. So we'll have x squared plus 6x plus x plus 6 equal to 0. Common factor, we have got x in bracket x plus 6 plus 1 in bracket x plus 6 equal to 0. So that gives us x plus 1 in bracket x plus 6 is equivalent to 0. So this suggests that x plus 1 is equal to 0, or x plus 6 is equal to 0. So x is equals to minus 1, or x is equals to minus 6. That is the answer for that. Number 22, solve the equation. So in number 22, we are given log of 6x minus 2, everything to base 10, minus 1 should give us log of x minus 3, everything to base 10. So this will give us log of 6x minus 2 to base 10 minus this one here must be converted into a number, into a log form, so that what we are supposed to have here is supposed to read log of something. You can say, for example, log of x to base 10. So if we have got log of x to base 10, which is supposed to be equivalent to 1, then can we get the value of x? We must know that this is in terms of logarithmic notation. So if we want to get the value of x, we convert the equation into index notation, and we'll say that 10, which is the base, 10 to power 1 should give us x. So 10 is equivalent to x. So log of 10 to base 10 is equivalent to 1. Last time when we were talking about the laws of logarithm, we said that log of a number to its base is 1. Can have log of 10 to base 10 is 1. Log of 12 to base 12 is 1. Log of 3 to base 3 is 1. So log of a number to its base is 1. So instead of having this 1 here, we can say this is equivalent to log of 10 to base 10 should be equals to log of x minus 3 to base 10. Then we need to know that log of x minus log of y to any base, log of x minus log of y to any base, be it base 10, base 1, base 3. Log of x minus log of y can be written as log of x over y. So in my case here, I have got log of 6 minus 2 to base 10. Take away log of 10 to base 10 can be written as log of 6x minus 2 over 10, everything to base 10, should give us log of x minus 3 to base 10. So the base cancel, and the log. So we are left with 6x minus 2 over 10 should be equals to x minus 3. So cross multiply, we'll have 6x minus 2 should be equals to 10 in bracket x minus 3. So this is supposed to give me 6x minus 2 should be equals to 10x minus 30. Collect the like terms. 6x minus 10x should be equals to minus 30 plus 2. We get minus 4x should be equals to minus 28. X alone is equals to minus 28 divided by minus 4, giving us x as 7. That is the answer for that. Number 23. Evaluate without using mathematical tables the expressions. So we are given 2 log of 5 to base 10. Remember, if you have got x log of y to any base, be it to base 10, for example, this is the same as log of y to power x to base 10. Even if it is b log of x to base 3, you know that this is log of x to power b to base 3. So if we have got 2 log of 5 to base 10, remember this can be written as log of 5 to power 2 to base 10 minus, we now have a half log of 16 to base 10 can be written as log of 16 to power a half to base 10. And remember, we said that if you have got 16 to power a half, this is the same as the square root of 16. If you have got x to power a half, this is the same as square root of x. If you have got x to power 1 over 3, this is the same as the third root of x. If you have got x to power 1 over 4, this is the same as the fourth root of x, like that. So in our case here, we have got In our case here, we have log of 16 to power a half to base 10, which is the same as log of square root of 16 to base 10, which is the same as log of 4 to base 10. So instead of having a half log of 16 to base 10, what we are going to have log of 4 to base 10 plus 2 log of 40 to base 10. Remember, this can now be written as log of 40 to power 2 to base 10. So, which is the same as, this is going to give us log of 1600 to base 10. So this is log of 1600 to base 10. So now we have got log of 25 to base 10 minus log of 4 to base 10 plus log of 1600 to base 10. Then, because we know that we can rub, let's have a space, because we know that if you have got log of y minus log of x to any base, be it to base b, this is supposed to be the same as log of y over x to base b. So, in our case here, because we are dealing with the log of 25 to base 10 minus log of 4 to base 10, this can be written as log of 25 over 4 everything to base 10 plus log of 1600 to base 10. Now, we know that log of y to any base plus log of x to any base can be written as log of y times x. So, we are dealing with log of 25 over 4 to base 10 plus log of 1600 to base 10 can now be written as log of 25 over 4 times 1600 everything to base 10. So 4 goes here once, 4 goes here 400. So we'll have 25 times 400, giving us 2500 times 4, 0, 0, 0, 8, 10. So this is supposed to give us log of 10,000 to base 10. And log of 10,000 to base 10 is equivalent to 4. It's equivalent to 4. Because we know we'll have, why are we saying it is equivalent to 4? We have log of 10,000 to base 10 is equivalent to log of 10 to power 4 to base 10. Because it is 10 times 10 times 10 times 10 that gives us 10,000. So that is 10 to power 4 to base 10. This can be written as 4 log of 10 to base 10. And log of a number to its base. Log of a number to its base is equivalent to 1. So we'll have 1 times 4, we get 4. That is why we are saying log of 10,000 to base 10 is equal to 4. So our answer is equals to 4. Number 25. Find without using mathematical tables the value of x that satisfy the equation. So in our case here we are given log of x squared minus 9 to base 2 is equals to 3 log of 2 to base 2 plus 1. Let's move together. We have got log of x squared minus 9 to base 2 should be equals to, remember, if you have got x log of y to any base, can be written as log of y to power x to base b. So in our case, we have got 3 log of 2 to base 2 can be written as log of 2 to power 3 to base 2. So in our case here, this is going to give us log of 8 to base 2. Because 2 to power 3, remember 2 to power 3 is 2 times 2 times 2, which 2 times 2 is 4, 4 times 2 is 8. So we'll now have log of 8 to base 2 plus 1. We don't want this one here. We don't want this one here. We don't want this one here. Instead of having 1, let's convert it into log of something to base 2, the base that we are dealing with, to base 2. So log of y to base 2 should give us 1. What is y? Now you convert this into index notation, and you'll say, if you convert it into index notation, you'll say 2 to power 1 is equals to y. So 2 is equals to y. So we are going to have now 1 being equivalent to log of 2 to base 2. And we also know that log of a number to its base is equal to 1. So instead of having 1 and we are dealing with 2 base 2, we'll say this is the same as log of 2 to base 2. Let's continue. Now we have got log of x squared minus 9 to base 2 should give us log of, we know log of x maybe to power base b plus log of y to base b can be written as log of x times y everything to base b. Now because we are dealing with 8 and 2, log of 8 to base 2 plus log of 2 to base 2, this can be written as log of 8 times 2 to base 2. So we'll have log of x squared minus 9 to base 2 should be equals to log of 16 to base 2. So the base and the log cancel each other. We have got x squared minus 9 equal to 16. X squared is equal to 16 plus 9. X squared is equal to 25. So x alone is equal to root of 25. X is equal to plus or minus 5. So x can either be 5 or x is equal to minus 5. That is the answer for that. Number 25. Without using mathematical tables or calculator, evaluate. So we are given 6 log of the third root of 64 to base 2 plus 10 log of the fifth root of 243 to base 3. Let's now work it out. What is the third root of 64? If you have got 64, you can break it into prime numbers. You'll have 32, 16, 8, 2 goes there, 4, 2 goes there, 2, and finally 2 goes there, 1. So in terms of prime factors, this is what we have. So because we are taught this thing in Form 1, we can be able to have 2 times 2 times 2 times 2 times 2 times 2. So According to me, this is what I'll do. So I'll have 4 times 4 times 4. So the third root of 64, according to me, I'll get it is 4. So I'll have 6 log of 4 to base 2 plus 10 log of, let's do the same for 243. Let's get the prime factors. 243, I'll start with 3. 3 goes there, 81. I'll go to 3, 27, 3, 9, 3, 3, and finally 3, 1. So we have 3 times 3 times 3 times 3 times 3, which is equivalent to 3 to power 5. Excuse me. So the fifth root of 243 is 3, and we have to base 3. Let's move. Now what we have, we know that if we have got b log of y to base x, for example, this can be written as log of y to power b to base x. So if I have got 6 log of 4 to base 2, this can be written as log of 4 to power 6 to base 2. So I'll have log of 4 to power 6 to base 2 plus the same if I've got 10 log of 3 to base 3 can be written as a log of 3 to power 10 to base 3. So this will give me log of 3 to power 10 to base 3. Then where am I heading to? Am I going to get anything? No. What about if we take it this way? Let's ignore this. Let's ignore this. And let's work it out this way. 6 log of 4 to power 2 plus log of 3. This is 10 to base 3. We now have 6 log of 4. 4 can be written as 2 to power 2 to base 2 plus 10 log of 3 to base 3. We know that if you have got log of x to power b to base a can be written as b log of x to base a. So if we have got log of 2 to power 2 to base 2 can be written as 2 log of 2 to base 2. So in our case here we'll have 6 times 2 log of 2 to base 2 plus 10 log of 3 to base 3. So we'll have 12 log of 2 to base 2 plus 10 log of 3 to base 3. And remember that log of a number to its base is 1. Remember that if you have got log of b to base b is equivalent to 1. So in our case here, because we have got log of 2 to base 2, which is the same as 1 plus 10 times log of 3 to base 3, which is 1. So we'll have 12 plus 10, giving us 22 as the answer. Number 26. Given that log of 4 equal to 0.6021 and log of 6 equal to 0.7782, without using mathematical tables or calculator, evaluate log of 0.096. So we have log of 0.096. Given that log of 4 is equivalent to 0.6021 and log of 6 is equivalent to 0.7782. So we know that 96 is divisible by both 4 and 6. So let's do it this way. Log of 96 can be written as log of 0. We have 0.096 can be written as log of 96 divided by 1000. Because we know that if we have got 96 divided by 1000, it will be 0.096. So we now have log of 96 over 1000. And we know that log of x over y can be written as log of x minus log of y. So log of 96 over 1000 can be written as log of 96 take away log of 1000. Let's continue. Log of 96. Log of 96. If we have got 96, let's get the prime factors. 2 goes there, 48. 2 goes there, 24. 2 goes there, 12. 2 goes there, 6. 2 goes there, 3. And 3 goes there, 1. So 96 can be written as 2 times 2 times 2 times 2 times 2 times 3. So this is the same as 4 times 4 times 6. So which is the same as 4 squared times 6. So instead of having log of 96, we can have log of 4 squared times 96. So this will give us log of 4 squared times 6 minus log of 1000. Let's continue. We know that if we have got log of a times b, this can be written as log of a plus log of b. So in our case, we have got log of 4 squared times 6 can be written as log of 4 squared plus log of b. So in our case here, we'll have log of 4 squared plus log of 6 minus log of 1000. This is going to give us 2 log of 4 plus log of 6 minus log of 10 to power 3, which is the same as 2 log of 4 plus log of 6 minus 3 log of 10. So what are we going to have? We are given, let's go back, we are given log of 4. We are given log of 4 as 0. Log of 4 we are given as 0.6021 and log of 6 as 0.77782. So where log of 4 is, we substitute with this, and where log of 6 is, we substitute with this. So what we are going to have, we are going to have 2 log of 4, which is times 0.6021, plus log of 6, which is 0.7782, minus 3 log of 10. You know, if it is log of 10, you must know that it is log of 10 to base 10, and log of a number to its base is 1. So this is 3 times 1. So we'll have 0.6021 times 2. We'll have 24021. So we'll have 1.2042 plus 0.7782 minus 3. So if I add to 0.7782, I get 4, I get 2, I get 8, I get 9, and 1. So I'll have 1.9824. Take away 3. What am I going to have? So it's like it will have 3 minus 1.9824. 0, 0, 0, 0. So I'll have 6, remainder 9. I'll have 7, remainder 9, 1, remainder 9, 0, 1. So I'll have 1.0176. That is the answer for that. Number 27. Solve for y in the equation. So number 27 is saying log of 3y plus 2 in bracket to base 10 minus 1 equals to log of y minus 4 to base 10. So we'll have log of 3y plus 2 everything to base 10 minus this one whole number here. We want to express it such that we are going to have log of a number y to base 10, because we are dealing with base 10. Base 10 should give us 1. So if you have got log of y to base 10 supposed to give me 1, what is the value of y? So we must know that this is in terms of logarithmic notation. If you want to find the value of y, convert the equation into index notation. So what you are going to have, you'll say 10, which is the base, to power 1 should give me y. So I'll have log of 10 to base 10 is equals to 1. So instead of having 1 here, I'll have log of 10 to base 10 should give me log of y minus 4 to base 10. Then from there, what are we supposed to do? Because we know the laws of logarithm. If you have got log of x maybe to base 10 minus log of y to base 10, remember this can be written as log of x over y to base 10. So in our case here, we have got log of 3y plus 2 to base 10 minus log of 10 to base 10. This is equivalent to log of 3y plus 2 over 10, everything to base 10, should be equals to log of y minus 4, everything to base 10. So log cancel with log, the base cancel with the base. So we'll have 3y plus 2 over 10 is equals to y minus 4. Then you cross multiply. If you cross multiply, you'll have 3y plus 2 should be equals to 10 in bracket y minus 4. So that will give me 3y plus 2 should be equals to 10y minus 40. I'll have collect the like terms. 3y minus 10y should be equal to minus 40 minus 2. So this is minus 7y should be equal to minus 42. Y alone should be equal to minus 42 over minus 7. So y alone is equals to 6. 6. And that is the answer for that. Number 28. Find the value of x given that log of. So what are we given? We are given log of 15 minus 5x minus 1 is equivalent to log of 3x minus 2. Remember that if we are not given the base, you are given it that way, log of x, you must know that this is to the standard base. It is log of x to base 10. So in our case here, we have got to base 10 to base 10. So we'll have log of 15 minus 5x, everything to base 10, minus 1. This one, we don't want it here. We want it to be log of something to base 10 that is going to give us 1. And we know that log of a number to its base is 1. So if we are dealing with the log to base 10, then we'll have log of 10 to base 10, which is going to give us 1. So instead of having 1 here, we say this is equivalent to log of 10 to base 10. So this is equivalent to log of 3x minus 2 to base 10. Then remember, if you have got log of x to base 10 minus log of y to base 10 is equal to log of x over y, everything to base 10. So here we are dealing with log of 15 minus 5x to base 10, take away log of 10. That is the same as log of 15 minus 5x, everything to base 10, over 10, everything to base 10 should give us log of 3x minus 2, everything to base 10. So log cancel out, the base also cancel out. We have got 15 minus 5x over 10 is equals to 3x minus 2. Then we cross multiply. We get 15 minus 5x is equals to 10 in bracket 3x minus 2. That will give me 15 minus 5x is equals to 30x minus 20. So collect the like terms. We'll have minus 5x minus 30x should be equals to minus 20 minus 15. So minus 35x should give me minus 35. X alone should be equals to minus 35 over minus 35. X is equals to 1. Like that. Number 29. Without using mathematical tables or a calculator, solve the equation. So this is what we have. We have got 2 log of x to base 10 minus 3 log of 2 to base 10 plus log of 32 to base 10 equals to 2. So remember, if we take this one, 2 log of x to base 10, we know that if you have got b log of x to base a can be written as log of x to power b to base a. So if we have got 2 log of x to base 10 can be written as log of x to power 2 to base 10. So this one will have log of x to power 2 to base 10 minus, what about if you now have 3 log of 2 to base 10 is equals to log of 2 to power 3 to base 10. So minus log of 2 to power 3 to base 10 plus log of 32 to base 10 equals to 2. We don't want to deal with the whole numbers here. This one must be converted into log of something to base 10 that is going to give us 2. So we'll say log of something, a value y to base 10 should be equals to 2. That is in logarithmic notation. If you want to get the value of y, you convert into index notation. So we'll have 10, this 10 here, 10 to power this 2 to power 2 should give us y, this y here should give us y. So this is 100 should be equals to y. So instead of having 2, we can have log of 100 to power 10 to base 10. So this is log of 100 to base 10. Let's continue. We'll now have log of x squared to base 10 minus log of 2 to power 3 is the same as 2 times 2 times 2, giving us 8. Log of 8 to base 10 plus log of 32 to base 10 equivalent to log of 100 to base 10. We also know, let's rub first. We also know that if you have got log of y maybe to base 10 minus log of x to base 10, this can be written as log of y over x, everything to base 10. So in our case, we are dealing with log of x squared to base 10 minus log of 8 can be written as log of x squared over 8, everything to base 10, plus log of 32 to base 10 equals to log of 100 to base 10. If you have got log of y maybe to base 10 plus log of x maybe to base 10 can be written as log of y times x, everything to base 10. So in our case here, we are dealing with the log of x squared over 8 to base 10 plus log of 32 to base 10 can be written as log of x squared over 8 times 32, everything to base 10 equals to log of 100 to base 10. So the log cancel out, 10 cancel out as the base. So what we now have x squared over 8 times 32 should give me 100. So 8 goes here 1, 8 goes here 4. So 4x squared is equals to 100. Divide both sides by 4. We get x squared is equals to 25. X alone is square root of 25. So x is equals to plus or minus 5. So in our case, x is equals to 5 or x is equals to minus 5. That is the answer. Number 31. Solve the equation 2 log of x minus log of x minus 2 equals to 2 log of 3. So we have got 2 log of x minus log of x minus 2 equals to 2 log of 3. We all know if you are given b log of y, this can be written as log of y to power b. if you have got 3 log of x, we know that this can be written as log of x to power 3. So in our case here, 2 log of x can be written as log of x to power 2. So we are saying if you have got 2 log of x, can be written as log of x to power 2 minus log of x minus 2 equals to, if you have got 2 log of 3, know that it can be written as log of 3 to power 2, and log of 3 to power 2 is equals to log of 9. So instead of having 2 log of 3, we'll have log of 9. So from here, we know that if we have got log of a minus log of b, can be written as log of a over b. So in our case, we have got log of x squared minus log of x minus 2 can be written as log of x squared over x minus 2 should be equals to log of 9. So you cancel log, we have x squared over x minus 2 should be equals to 9. So cross multiply, you'll get x squared is equals to 9 bracket x minus 2. This is going to give us x squared is equals to 9x minus 18. Collect the like terms, x squared minus 9x equals to minus 18, which is the same as x squared minus 9x equals to, take away a plus, because minus 18, when it comes to the left-hand side, then we'll have plus 18 equal to 0. So this is a quadratic equation that can be solved. You can solve this one by factorization method, whereby we are going to look for two numbers that if you multiply, it's going to give us positive 18, and if you add, it's going to give us minus 9. And that is, we'll have minus 3 and minus 6. So we'll have x squared minus 3x minus 6x plus 18 equal to 0. Collect the like terms, we'll have x in bracket x minus 3 minus 6 in bracket x minus 3 equal to 0. So x minus 6 in bracket x minus 3 is equal to 0. So x minus 6 is equal to 0, or x minus 3 is equal to 0. So x is equal to 6, or x is equal to 3. That is the answer. Number 32, solve the equation. We are given 2 log of 15 minus log of x equals to log of 5 plus log of x minus 4. So we are given 2 log of 15 minus log of x should give us log of 5 plus log of x minus 4. We know that if you have got b, log of a can be written as log of a to power b. So if we have got 2 log of 15, we know that this can be written as log of 15 to power 2. So, and log of 15 to power 2 is the same as log of 225. So we'll have, instead of having 2 log of 15, we'll have log of 225 minus log of x should give us log of 5 plus log of x minus 4. Then we also know that if you have got log of y, take away log of x, can be written as log of y over x. So this one will give us, we have log of 225, take away log of x, that will give us log of 225 over x, should give us, then we also know that log of y plus log of x is equivalent to log of y times x. So in our case, we have got log of 5 plus log of x minus 4. That will give us log of 5 in bracket x minus 4 because we are multiplying. So the log cancel with the log. We are left with 225 over x, which should be the same as 5 in bracket x minus 4. This is going to give us, we have 225 over x should be equals to 5x minus 20. Then this is going to give us, if you cross multiply, 225 should be equals to x in bracket 5x minus 20. Then we'll have 225 should be equals to 5x but squared minus 20x. So this is the same as this is the same as 5x squared minus 20x minus 225 should be equals to 0. So you can divide everything by 5, by 5, by 5. Then we'll have x squared minus 4x minus 4. It goes there 4 times, remember 225 is got there 5, should be equals to 0. So this is a quadratic equation. This has led us to a quadratic equation whereby we can be able to solve it using factorization method, whereby we need to find out whether there are two numbers that if you multiply are going to give you minus 45, and if you add are going to give you minus 4. So the two numbers are minus 9 and positive 5. So we continue and say we'll have x squared minus 9x plus 5x minus 45 equal to 0. So x in bracket x minus 9 plus 5 in bracket x minus 9 should give us 0. So x plus 5 in bracket x minus 9 should be equivalent to 0. So x plus 5 is equal to 0, or x minus 9 is equal to 0. So x is equal to minus 5, or x is equal to minus 9, positive 9. Positive 9, and that is the answer for that. Number 33. Number 33, find the value of x given that log of. So we have got log of x minus 1 plus 2 should be equal to log of 3x plus 2 plus log of 25. So this is going to give us log of x minus 11 plus, instead of having 2, we can convert it into log form and says that 2 is equivalent to log of a given number to base 10. Because we are dealing with the standard base. If the bases are not indicated, then you must know that you are dealing with the standard base, and the standard base is to base 10. So that is why we are saying 2 can be written as log of a given number to base 10. So if you want to find this number y, then you must convert this from logarithmic notation to index notation, whereby you are going to say 10, which is the base, if you raise to power 2, she'll give you y. So you know that y will now be 100. So 2 can also be written as log of 100 to base 10. So we'll have log of 100 to base 10 is equals to log of 3x plus 2 plus log of 25. So we continue and say, and now that we know that if you are given log of y plus log of x can be written as log of y times x. So in our case here, we have got log of x minus 11 plus log of 100. That can be written as log of x minus 11. Then you multiply it by 100. Like that should give us, on the right hand side, we have got log of 3x plus 2 plus log of 25. That is going to give us log of 3x plus 2 times 25. So this is going to give us log of 100 in bracket x minus 11, like that, should be equals to log of 25 in bracket 3x plus 2. Then the log cancelled with the log. We have got 100 in bracket x minus 11 should be equals to 25 in bracket 3x plus 2. So that is going to give us 100x minus 1100 should give us 75x plus 50. Collect the like terms. We'll have 100x minus 75x should be equals to 50 plus 1100. So this will give us 25x should be equals to 1150. So divide both sides by 25 by 25. So we'll have x is equals to, we know that 5 goes there 5, 5 goes here 2, 3, 0, 5 goes there 1, 5 goes there 4, 6. So the answer will be 46, and that is the value of x. Number 34. Solve the simultaneous equation below. So we are given log of y to base x is equals to 2. So what we must know is that these 2 can be converted into log of a number to base x. This can be converted into log of a number to base x. Now that log of y to base x, we have got 2 unknown here, and we are given log of y to base x is equals to 2. You must know that this is in terms of logarithmic notation. So if you want to get the value of y, here you'll say x to power 2 should give us y. So in our case, we say y is equivalent to x to power 2. Then this we can say this is our first equation. Then we also know that xy is equals to 8. This is our second equation. So in our first equation, we are given y is equals to x squared. Then in the second equation, x times y. And what is y? Y in the first equation has been gotten as x squared should give us 8. So that is x to power 3 should be equals to 8. So that means x to power 3, which is equals to 8, hence x is equals to the third root of 8. So x is equivalent to 2. That is the value of x. Now what is the value of y? We also know that x times y is equals to 8 according to the second equation. X times y is equals to 8 and x is 2, so 2 times y should give me 8. 2y should be equivalent to 8. Y should be equals to 8 over 2. Y should be equals to 4. And that is how that question is supposed to be done. Number 35. Solve the simultaneous equation below. So we are given 2 log of y is equals to log of 2 plus log of x. That is what we are given. And we know very well that if you are given b log of y, this can be written as log of y to power b. So 2 log of y can be written as log of y to power 2. So in our case here, instead of having 2 log of y, we can say this is the same as log of y to power 2 is equals to log of 2 plus log of x. We are still dealing with the first equation, this first equation. We want to simplify it. So, and we know that log of y plus log of x supposed to be equals to log of y times x. So we'll have log of y squared should be equals to log of 2 times x. So log of y squared should be equals to log of 2x. So log cancel out. Then we are left with y squared is equals to 2x. So if we divide both sides by 2, then we'll say that x is equals to y squared over 2. Can say let this be equation 1, like that. Once you've gotten equation 1, equation 2, according to the second equation, we are given 2y. It is 2 to power y. 2 to power y is equals to 4 to power x. 2 to power y is equals to 4 to power x. So what we can do here, we are given 2 to power y is equals to 4 to power x. Remember x in our first equation, we were getting x is equals to y squared to power y squared over 2. That is the value of x. X was y squared over 2. So we have in the second equation we are given 2 to power y is the same as 4 to power x, and x is y squared over 2. So we have 2 to power y is equals to, this can be written as 2 to power 2 because that will give us 4 raised to y squared to power 2. So this is the same as 2 to power y is equals to 2 to power 2 times a half everything to power y squared. So that will give us 2 to power y should be equals to 2 to power, this one cancel out, we are left with 1, everything to power y squared. So what we have is 2 to power y will be equals to 2 to power y squared. So if the bases are the same, if the bases are the same, you equate the powers. So we'll have y is equivalent to y squared. So if you collect the like terms, you'll say y squared minus y is equal to 0. Common factor y in bracket y minus 1 is equal to 0. So y is equivalent to 0, or y minus 1 is equal to 0. So we'll have y is equal to 0 or y is equals to 1. So that is the value of y. And what was our x? Our x, remember x was given as y squared over 2. Y squared over 2. So if y is equal to 0, x will be equal to 0 squared over 2, which is the same as 0. And if y is equals to 1, x will be equals to 1 squared over 2, x will be equals to a half. That is the value for that. Number 36. Solve the simultaneous equation below. You are given log of x plus y equal to 0. And you know, if you are given log of y, you must know that this is to base 10, which is this to the standard base. If you have got log of b, without them indicating the base, you must know that you are dealing with log of a number to a standard base. So in our case here, we have got log of x plus y to base 10. So this 0 here must be converted into log of a number to base 10, that is going to give us 0. And you must know that log of 1 to any base, be it to base 10, be it to base 8, is 0. Log of 1 to any base is 0. Log of 1 to any base is 0. So we'll have log of x plus y should be equals to log of 1. The base is to base 10. So the log cancels. So we'll have x plus y should be equivalent to 1. This is the first equation. Second equation, we have got 2 log of x should be equals to log of y plus 1 from this. And we know that b log of y can be written as log of y to power b. So 2 log of x can be written as log of x squared. So we'll have log of x squared should be equals to log of y plus 1. So you must know that the log will cancel out. So we'll be left with x squared is equals to y plus 1. And this is our second equation. So we have got 2 equations. We have got x plus y is equals to 1, and x squared is equals to y plus 1. So this can be solved using the substitution method. You can say from the first equation, we can have x is equivalent to 1 minus y. So from the first equation, this first equation, x is equivalent to 1 minus y. Then substituting this for x in the second equation, so where there is x, we replace with 1 minus y. So x squared for the second equation. So we'll have 1 minus y squared should be equals to y plus 1. Why are we substituting? So that we remain with one unknown. So we'll have 1 minus y in bracket 1 minus y should be equals to y plus 1. So we'll have 1 minus y plus y squared is equals to y plus 1. So 1 minus 2y plus y squared is equals to y plus 1. So keep on collecting the like terms. We'll say 1 minus 2y plus y squared minus y. If this comes to the left hand side, minus 1 equal to 0. So we'll have y squared minus 2y minus y plus 1 minus 1 equal to 0. So y squared minus 3y, we have y squared minus 3y equals to 0. So y is common factor in bracket y minus 3 equal to 0. So that is going to give us y is equivalent to 0 or y minus 3 is equal to 0. So y is equal to 0 or y is equals to 3. So that is the value of y. What about the value of x? How did we find x? We were saying x can be got by x is the same as 1 minus y. So you'll continue and say if y is equal to 0, x will be equals to, and x is got by 1 minus y, which is minus 0. So x will be equals to 1. So when y is 0, x is 1. What about if y is equals to 3? What is the value of x? So we are given x is equals to 1 minus y, and y is 3. So x will be equals to minus 2. So when y is positive 3, x is negative 2. And that is the answer for that. Number 37. If log over x to base 2 plus log of 2 to base x is equals to 2, find x. So we are given log of x to base 2 plus log of 2 to base x equals to 2. So this is a little bit complicated, but there's a way out. What you can say, or what you can do, you'll say let y be equals to log of x to base 2. So y is equivalent to log of x to base 2. So where log of x to base 2 is, you replace with y. So in my case here, I have got log of x to base 2. Then you must know, there's a law that we must also know. We know that if you have got log of b to base a can be written as log of a to base b 1 over log of a to base b. Let me repeat. If you have got log of, for example, x to base y, this can be written as 1 over log of y to base x. For example, if you have got log of 3 to base 10 is the same as 1 over log of 10 to base 3. So in our case here, we have got log of x to base 2 here. Then here they have changed. It is now log of 2 to base x. So that means that what we have log of x to base 2 plus this one can be written as 1 over log of x to base 2 equal to 2. And we had said y is equivalent to log of x to base 2. So where log of x to base 2 is, you replace with what? Y. So we'll have y plus 1 over y is equals to 2 over 1. LCM is y. 1 goes into y times y, y squared, plus y goes into y 1 times 1, 1 is equivalent to 2. So we have y squared plus 1 over y is equals to 2. So y squared plus 1 is equals to 2y through cross multiplication. Collect the like terms, you'll say y squared minus 2y plus 1 is equal to 0. Then this is a quadratic equation that can be solved using factorization method. So we are supposed to look at two numbers that if you multiply is going to give you positive 1, and if you add it's going to give you negative 2. So two numbers if you multiply positive 1, so that is minus 1 and minus 1. So we'll have y squared minus y plus 1 equal to 0. So y is common in bracket y minus 1 plus minus 1 in bracket y minus 1 equal to 0. So that will give us y minus 1 in bracket y minus 1 is equal to 0. So y minus 1 is equal to 0, or y minus 1 is equal to 0. So y is equals to 1. So the value of y is 1. And what was our y? Remember, according to our assumption is that we had log of x to power 2 is equals to y. And if you look at our value of y is 1. So we'll say log of x to base 2 is equals to 1. So we must know that this is in terms of logarithmic notation, which if converted to index notation, then we are going to get the value of x. So we'll say 2, this 2 here, to power 1 should give us x. So x is equals to 2. So that is the value of x. That is the value of x. Number 38. Number 38 we have got. Number 38 we have log of x to base 10 everything squared is equals to 3 minus log of x squared to base 10. So this is the same as log of x to base 10, everything squared, equals to 3 minus 2 log of x to base 10. So if you look at this equation, we can say let y be equals to log of x to base 10. Let y be equals to log of x to base 10. So where this log of x to base 10, let's replace it with y. So we'll have y squared is equals to 3 minus 2y. Collect the like terms, you'll have y squared plus 2y. This 3, when it comes to the left, also will have minus 3 equal to 0. So what we have is a quadratic equation that can be solved using factorization method, whereby we are going to find two numbers that if you multiply are supposed to give us minus 3, and if you add, we are supposed to have positive 2. So the two numbers we can have 3 and minus 1. So we'll have y squared plus 3y minus y minus 1 equal to 0. So y is common, in bracket y plus 3. So here we have got 3. Y in bracket y plus 3 minus 1 in bracket y plus 3 equal to 0. So y minus 1 in bracket y plus 3 is equivalent to 0. So y minus 1 is equal to 0, or y plus 3 is equal to 0. So y is equals to 1, or y is equals to minus 3. And what was our y? Our y, we know that log of x to base 10 is equals to y. So if y is equals to 1, what is x? So we'll have log of x to base 10 is equals to 1. So that is the same as log of x to base 10 is equals to log of 10 to base 10, because we know that log of a number to its base is 1. So the log and the base cancel each other, then we are left with x is equals to 10. So that is the value of x. What about if y is equals to minus 3? And we know that log of x to base 10 is equals to y, which is equals to minus 3. So what is x? So we must convert this into index notation, whereby we'll say 10, which is the base, to power minus 3 is equals to x. So 10 to power minus 3, if you have, for example, if you have got x to power minus 3, can be written as 1 over x to power 3. So this is the same as 1 over 10 to power 3 is equals to x. So x is equals to 1 over 1000. That is the answer for that. Number 39. Find y without using tables if 2 log of 3 to base 2 plus log of y to base 2 equals to log of 5 to base 2 plus 1. So this is what we have. We have got 2 log of 3 to base 2 plus log of y to base 2 equals to log of 5 to base 2 plus 1. So this one is plus, sorry, this is plus. So what are we going to do? We can collect the like terms. We'll say 2 minus 1 should be equivalent to 2 minus 1 should be log of 5 to base 2 minus log of 3 to base 2 minus log of y to base 2. So we'll have 1 here is equals to log of 5 to base 2 minus log of 3 to base 2 minus log of y to base 2. And we know that log of a number y minus log of a number x can be written as log of y over x. So that will give us 1 is equals to log of 5 over 3 to base 2 minus log of y to base 2, like that. Sorry. So we have 1 is equals to log of 5 over 2 y to base 2. So this one here can be converted into log of a number y to base 2. So how do we get y? We'll have 2 to power 1 is equals to y. So 1 can be written as log of 2 to base 2. So log of 2 to base 2 is equals to log of 5 over 2y to base 2. Log goes with the log, and the base also goes with the base. So we'll have 2 is equals to 5 over 2y. Then we'll cross multiply and say 2 times 2y is equals to 5. So 4y is equals to 5. Y is equals to 5 over 4. Y is equals to 1.25. That is the value of y. Number 40. Solve for x in log of x plus log of 5 equals to 30. So we have log of x plus log of 5 equals to log of 30. And we know that log of y plus log of x should give us log of y times x. So log of x plus log of 5 can be written as log of x times 5 should be equals to log of 30. The log cancel out. So we have 5x is equals to 30. Divide both sides by 5 by 5. So x is equal to 6. And that is the answer.